In lecture 14 we will discuss mainly the inverse Laplace transform and different methods used to find the inverse Laplace transform. And one method is inverse by using formula, another method is known as by using transform pairs, and the third one is a partial fraction. In lecture 14 mainly we will discuss the first two methods, okay, and we will also do some problems related to this topic. Okay, first we will discuss the different method. The first one is inverse formula. Okay, actually in order to calculate the Laplace transform, there is an inverse formula, that is x of t is equal to 1 by 2 pi j integral sigma minus j infinity to sigma plus j infinity x of s into e raised to minus, not minus, s plus st ds. Okay, so this integration is a complex integration. At this particular moment we will not discuss much about this inverse formula. We will mainly use the other two methods, okay, the table transform methods and the partial fraction method. Very easily we can find the inverse by using the method 2 and 3. So method 1 we will not prefer in this particular discussion. So this is a general formula to calculate the inverse Laplace transform. Okay, next we will discuss the table transform method. Okay, we know the basic transforms of most of the signals. Okay, by using this transform table I can find what will be the signal. For example, if the transform is 1, we know that the signal is impulse. Okay, similarly if the transform is 1 by s, the time domain signal is u of t, that is a step signal. And also remember that the ROC is sigma greater than 0, or you can say real part of s greater than 0. And if the signal is multiplied by t into u of t, okay, then there will be 1 by s square. So if there is a term 1 by s square, definitely it will be t into something. And in general, instead of studying t into, there can be t square, t cube, etc. So you need to remember, if it is k, t raised to k, the equation will be like this: k factorial by s raised to k plus 1. So if you know this relation, you can simply calculate t also. Okay, if t is 1, is 1 factorial by 1 plus 1, that is s square. So I think we can study this formula, then you can apply for any value of k. So next one is a very causal signal, e raised to minus at into u of t. Okay, the transform is 1 by s plus a, and remember that the ROC, okay, ROC is real part of s greater than real part of a, or in simple terms you can write, if it is a real quantity, sigma greater than minus a also. And the same transform we will get, but the ROC is different. Here sigma is less than minus a. So this is a causal signal. Okay, so this is a causal signal and this is an anti-causal signal. So you need to remember these two results, is very important. Okay, and another one, slightly the modified version of this t into u of t. Okay, similarly if there is a t into the causal signal, definitely there will be s square, and the same thing is applicable for anti-causal signal also. If t into the anti-causal signal is similarly 1 by s plus a whole square. Okay, or we can combine these two results, and ROC is also different. Anyway, you need to study this, very important, and this particular formula, this is also very important, and by using these two results we can write the other equations. So other two equations are very important. First I will discuss e raised to minus at, I will discuss this formula, e raised to minus at into cos omega 0 t into u of t. Okay, if it is cos omega 0, so there will be a term omega 0. Okay, and if it is cos, it will be s something. Okay, s plus a by something, and this e raised to minus a t is actually, you can see here, a and a, and the ROC is simply you can write, if it is a real quantity, sigma greater than minus a. If if you know this equation, if you simply substitute a is equal to 0, okay, a is equal to 0, you will get this equation, simply s by s square plus omega square. Okay, similarly, if you know this result, e raised to minus 80 into sine omega 0 t into u of t, it's simply omega 0. So this is the difference. If it is a cos signal, there will be s term in the numerator. If it is a sine term, there is only constant term. So we can see that omega 0, so omega 0, omega 0. And if it is minus a, there will be s plus a. Okay, so also you can think about it as a shifting property. Okay, if you multiply a signal with e raised to minus a t, it's known as shift property. And ROC is again same, sigma greater than minus a. And if you substitute a is equal to 0, again you will get this equation. Okay, sine omega 0 t d of t. So I think if you study these two results, it will be very easy to reduce the other two equations. Now we'll try some problems. So find the inverse Laplace transform of x of s is equal to 1 by s plus 1, real part of s greater than minus 1. Okay, and this is a very simple question, and there is one more quantity, sigma is greater than minus 1, and simply we will check the ROC. So this is j omega axis, and here it is minus 1, and real part of s greater than minus 1 like this. So this actually indicating this minus 1 is actually a causal signal. If it is causal signal, so you can see that if it is 1 by s plus a, so in the same form, okay, is 1 by s plus a. So you should write result in the causal form also. Okay, ROC is right of the pole. Okay, so we can write result in this form, x of t is equal to e raised to, in place of a you can put 1, so 1 into t, okay, u of t. So this is the result. Okay, e raised to minus t into u of t. So this is a causal signal. Okay. So now we will discuss next question. The same question, but the result you can see that ROC is less than minus 1. So this is a s plane, j omega minus 1 and sigma less than minus 1, or real part of s less than minus 1, means is actually indicating the ROC lies left of the pole. So this signal actually indicating the anti-causal signal. So we will choose the second option. So this is standard form, and ROC is less than something. Okay, and result is 1 by s plus a. So we can write result in anti-causal form. In a standard anti-causal form, always remember there is a minus. Okay, so when you write minus e raised to minus in place of a, you can write 1. So it's simply e raised to minus t into u of anti-causal signal, and you write u of minus t. So this is the result. Okay, is an anti-causal signal. Okay, we got the result. Now we'll move to the next question. It's simply s by s square plus 4. Okay, if you compare with the standard result, so there will be in this form, so s by something. So if you simply put a is equal to 0, the result becomes cos omega 0 t into u of t. So it can be written as s by s plus a, sorry, a is 0, so s square plus omega 0 square, and ROC is sigma greater than minus a. And if you compare these two equations, you can write the result like this, or if you rearrange this, it becomes s by s square plus 2 square. Sorry, this is not a is 0 here, so a is 0 here, so we can put 0. Okay, in this equation, if you put a is equal to 0, you will get cos omega 0 t into u of t, which is simply s by s square plus omega 0 and sigma greater than 0. So this is the standard form, and we modified the equation, so we can write it's cos in place of omega 0 it's 2, so cos 2t into u of t. So this is again a causal signal. Okay, causal signal. So ROC is like this, sigma greater than 0. This is the 0 plane and greater than 0. Okay. So next we'll discuss another question which is given s plus 1 divided by s plus 1 the whole square plus 4. So if we slightly modify this, it becomes s plus 1 by s plus 1 the whole square plus 2 square. And the ROC is sigma greater than minus 1, so it's a causal signal. And if you compare with the equation, okay, first equation, it becomes you can write x of t is equal to, by using the result, you can write s plus 1. So in place of 1 a, it's 1, so you can write e raised to minus 1t cos, in place of omega 0 it's 2, so cos 2t into u of t. Okay, again it's a causal signal because ROC is given something like this, or ROC is sigma greater than minus 1. So this is a point minus 1 and sigma greater than minus 1. So this is j omega axis and this is ROC, and indicating that this is a causal signal because ROC lies towards the right of the pole. Okay. So next question, here also you can see that s into something, but there is no s plus 1. Okay, if you do such question, you need to take some care. Okay, so I will first rewrite the equation like this. Either we need s plus a form, so we'll try to make it in s plus a form. So we'll write s plus 1 minus 1 divided by s plus 1 the whole square plus 2 square. Okay, if you split the equation like this, s plus 1 by s plus 1 the whole square plus 2 square minus 1 by s plus 1 the whole square plus 2 square. Okay, now it is in the standard form. So now we can compare the equations. So this equation will be in this form. Okay, the second one is a slightly modified version of the second one. So I can write the equation for s plus 1. Okay, I can use the first one. So if you write the s plus 1 by s plus 1 the whole square plus 2 square, the inverse Laplace transform can be written as e raised to minus t cos 2t into u of t. Okay, the signal is causal one, so we can write like this. And for the second signal, it's 1 by s plus 1 the whole square plus 2 square. So in order to make it in a standard form, we need omega 0 here. Okay, and lower portion also omega 0. So I will multiply with 2 here to cancel that. Again I will put a 2 here. So now we can write 1 by 2 e raised to minus t sine 2t into u of t. Okay, now we can combine these two results. So again it's a causal signal because sigma greater than indicating sigma greater than minus 1, so towards right. So this is ROC. So this is a g omega axis. So if you combine the result, finally your x of t becomes the first term will be e raised to minus t cos 2t into u of t minus 1 by 2 e raised to minus t sine 2t into u of t. Okay, so this is a causal signal because the pole ROC lies towards the right of this pole minus 1. Okay, I will do the same problem in another method also. So this is simple, or you can use this another property to solve this problem. So here you can see that if it is simply 1 by s plus 1 the whole square into 2 square. Okay, if it is in this form, it's almost similar to this sine equation. Okay, So in order to make it standard, I'll write 1 by 2 also here. So we need omega 0 at the numerator, okay, to make in this form. So if you write like this, it becomes 1 by 2 e raised to minus t sine 2t into u of t. Okay, now the equation is multiplied with s. Okay, so by using the differentiation property in time for the Laplace transform, okay, so if there is a signal d by dt into x of t, its transform will be simply s into x of s. So this equation is given s into something. So the signal s into x of s means assume that this is your x of s. Okay, if it is the x of s signal, so I can write like this, s into 1 by 2 into 2 by s plus 1 the whole square into 2 square. So this is your signal. The inverse Laplace transform, I can apply the differentiation property. So d by dt of 1 by 2, if it is s into, you need to put d by dt, e raised to minus t into sine 2t into u of t. Okay, if you differentiate this signal, you will get e raised to minus t cos 2t into u of t. Okay, and okay, already there is a 1 by 2 and this 2 will cancel, then plus e raised to sine 2t du of t into e raised to minus t into minus 1. So if you compare these two equations, you will get exactly the same previous one. Okay, so this way also you can do the question. Thank you.